All right, would like to welcome all of you to our webinar, depending where you are in the world, morning, afternoon, or evening, but on the GEODIS Park project and how we broke the mold in project delivery for that project. So I'd like to welcome each of our fellow panelists here, and if each of you could introduce yourself, your firm, and your role on the project. Bruce?
Yeah, hi. Thanks for attending. My name's Bruce Beahm. I'm with Populous. I served as project manager on the project, and Populous was engaged as the architect of record. And as you can see from the slide here, we also had Hastings Architecture. They were a partner of ours on the project and a co-designer and a huge team player for this project. Justin?
Sure. Hey, everybody. My name's Justin Barton. I'm a senior project manager with Walter P. Moore. We were the structural engineer on the team for the project. Also, you can see with MXE Consulting, that is a subsidiary of Walter P. Moore that was engaged to do some special aspects of the project. So I kind of oversaw our overall Walter P. Moore MXE team here on the job.
Taylor.
Hey, folks, I'm Taylor Gunkel. I'm a design phase executive with Mortenson. On this project, we had a Mortenson-Messer joint venture in association with BRG and Pinnacle. So a handful of local partners we were working with. I was the senior pre-construction manager on the job from basically early concept all the way over till we started operations, working hand in hand with the Populous team, Walter P. Moore, and CAA Icon. So was part of the process of actually working with Justin and the team on how we can deliver steel different and in a unique fashion, as well as part of hiring Lejeune as our steel fabricator.
And to follow up, I am Brent Beardslee with CAA Icon. I'm vice president there and also served as project executive for Nashville Soccer SC. All right, Bruce, if we can just kind of kick it off here, and we'll have you provide an overview of GEODIS Park.
Sure, Brent, glad to. So this first slide up here is just a kind of a location plan of where the project's located relative to the rest of Nashville. As you can see on the diagram, essentially it's on the southeast side of the Central Business District downtown. It's about a 2.5 mile drive. So the project is located in a neighborhood called Wedgwood, Houston. It's kind of one of the last areas of town close to downtown that's kind of being redeveloped. It's got a really proud history, and there's a lot of new development going on, which is very exciting. Go to the next slide. So we're kind of turning directions here on you. That previous slide, north was up, so sorry for that. So north in this image is to your right. So downtown will be to your right in this image. So this is a closer in look at the project site. The project itself is located in the Fairgrounds, Nashville area. This whole area has got a redevelopment plan that's the stadium was a big part of. The first phase of the project was the stadium sat on the grounds of some of the existing fairgrounds, show buildings, exhibit buildings, and that kind of thing, and they were in desperate need to be replaced and redone. So this area was completely demolished, and the stadium was built on the side of that area. As you can see around this area, there's other development going on, and these projects, the stadium serves as a catalyst for this development. There's mixed use development currently on the east side of the stadium between the Speedway and the stadium that is currently under construction. And then to the north, you'll see some additional mixed use development that will be developed in the near future. As you can see, you can go ahead and go to the next slide. we'll go through these plans at a kind of a quick pace, but we kind of want to give you a kind of a quick overview of the design itself. The plan to the left is the service level, and as I kind of go through this, this is kind of the back of house area, the south area we affectionately called the South Stack as we were designing the project. And this lower level is really all back of house function. It's your team locker areas, it's your loading dock, it's your maintenance areas, playing field equipment, that kind of stuff, big storage areas. And then there's field tunnel access to the loading dock off the end and from the loading dock and to the service yard area directly to the pitch. The next plan to the right shows the concourse. The concourse itself is essentially at grade, and then as you can see, the lower bowl is about 20 feet down, excavated down to the pitch level. And essentially the entire lower bowl is on grade, cast in place concrete on grade. And then except for the south portion there, the south portion is precast stadia on precast rakers. And the concourse circles north, east, and south sides. And then traditionally, as stadiums go, they're all the support functions. You get circled with concessions, restrooms, all the other fan amenities. That's on the north, east, and south sides. And then on the west side, we have we call it the premium stack. We have 3 distinct clubs, and that west building, we'll call it, it is the 3-story building as we go through the remainder of the slides here. And go to the next slide. So to the left is the next level up, the suite level. There's 27 separate individual suites. And then the next plan to the right is the press level. Self-explanatory, all the press functions. And then the upper bowl plan, you can see how the upper bowl encompasses the north, east, and south sides of the field. And then the canopy level to the right, we have a canopy that circles 360. If I remember right, Justin, correct me if I'm wrong, I think that's like over an 80-foot span on that canopy.
Yeah, we're about 85 feet from the back of the bowl out, so it covers the entire upper bowl and a decent portion of the lower bowl as well.
Yeah. Some quick facts and figures. Opening day, May 1st. Project cost was about $285 million. Gross square footage for the building's right around 544,000 square feet. About 30,000 seats total. And the site acreage is about 19 acres. These next 3 slides that we're going to show you, I think, are very interesting and dovetail. It's an important dovetail into our subject matter today. It gets into a little more detail. So what we're seeing here is a section perspective of the east sideline, and it kind of, what it does is it shows you a little more diagrammatic of how the building goes together. You can see these outbuildings where the concessions and restrooms are basically simple buildings, all load-bearing masonry walls with bar joists. The main structure, as you can see, the tall verticality, we expose and express the structure. And this is a common thing for stadia design because it's kind of a magnitude of scale issue. I mean, you get into as these buildings get very large, and sometimes we're just not fortunate enough to have the budget to completely wrap the exterior facade of these buildings. And so we express the structure, and it's it's part of the architecture. It's very important that as we get into our discussion today, you'll see the importance of what we want to talk about with steel design. So But going to this a little bit further, you can see that the upper bowl is all supported by the steel structure with, in the upper structure, I'm sorry, the upper bowl is all precast. And then the canopy, as you can see above that, is all steel frame and steel deck and a single membrane on top of that. Go to the next slide. This slide is through the south stack that we mentioned earlier, all the back of house space. You can kind of see there at the left. That's kind of cut right through the loading dock. And then this is cut through the west building, which we described earlier, and that's the premium stack. The club space there is at the concourse, and then above that, the suites and the press box. So yeah, that's kind of it. A quick run through the design of the building. But I might say one thing, kind of the industrial design aesthetic, as you can kind of see for the design of the building, kind of ties into the whole design statement that we established early on in this project, was that it was going to be uniquely Nashville. And this also ties into the heritage of the Wedgwood Houston area. It has a strong heritage of kind of a factory area, industrial area, and a lot of exposed brick and a lot of industrial type, exposed steel, concrete, brick, that kind of stuff. So with that, we'll go on to Brent to move us along here.
That sounds good. Thank you for the, giving us the lay of the land here. And then digging into the details there, Justin, maybe just kind of set you up to talk about what the genesis was here behind this thought process that Walter P. Moore as an organization and us as individuals, or you as individuals had in really breaking the mold of project delivery on GEODIS Park.
Yeah, happy to, Brent. Thanks. So this is the Paulson curve. You can see it's actually been around since 1976, talking about designing to reduce construction costs and just how early on in the project, we have a high degree of influence and for low expenditures, relatively low expenditures. And then as the project moves along, our level of influence decreases and the high expenditures happen. So kind of really reinforcing the idea that the more that we can plan and push things and make decisions and the right decisions early, it sets the whole project up for success later. So this was from 1976. Again, the same thing would apply to structural steel for that. Going in that same manner. And really once those kind of influence lines cross, that's really the point of the juxtaposition point. And really the project can go a variety of ways at that point. And really kind of the breadth of that cone really represents what we would kind of refer to as the project risk profile for the owner. Things could go well, things could not go well. But again, we don't have as much influence over those factors as we do early on in the project. So then thinking about that, okay, is there a way to kind of reduce that risk profile to narrow that cone? And so in taking kind of our influence line and pushing that forward, where we're actually now going to spend a little bit more influence early on and pushing that out and pushing that out further into the project lifecycle, we can see that that's going to result in a narrowed cone. So overall, we're just trying to, again, improve the influence curve to reduce the cost, overall cost, and schedule risk. And so, Taylor, you want to explain a little bit kind of specifically about steel?
Yeah. So, and a couple pictures we'll walk through to support some of our descriptions. But historically, especially on sports projects, steel can be the single largest trade partner contract we have. It also comes with some of the highest risk, and a lot of that revolves around a few key components. But one is simply the scale of the work and the fact that it lies on the critical path for the entire duration it takes place. So that's one key factor. The other is really, to Bruce's point, steel structures have evolved. They're now just as much an architectural element of the building. They're no longer simply a supporting structural element. And so because of that, structures have become much more unique and ornate, it's incredible, but it comes with a challenge and the task at hand. And so the next image here helps to really describe, well, where does the risk lie? And the risk in steel typically doesn't lie within the body of the steel member. It lies at the connections, the last 5 or 10%, right, of that steel member is really where the risk and the potential for a challenge exists. And so with our project team here, our goal was how can we essentially, to Justin's point, move some of these decisions and influence earlier on in the project and allow us to reduce the risk later on. And we'll kind of walk through how we actually brought this to fruition. And then towards the end, we'll kind of drop through what worked and why did we see the success. But really, it was about managing risk for Mortenson, Messer, the owner, as well as the design team, and making those decisions early on.
Yeah, and kind of one of the unique things about structural steel is that there's a lot of people and a lot of firms involved to get to that point where we're actually erecting steel on site. And one of the unique things about structural steel is that the process is we have to create what's called an advanced bill of material. Every piece of steel is rolled in a factory and then shipped out to the project fabricator's warehouse to be able to start that fabrication process. But in order to create that advanced bill of material, it creates a lot of pull requests upstream. There has to be a detailer involved to help create that advanced bill of material. That detailer traditionally has always worked underneath the fabricator scope. In order to have a fabricator on board, you have to bid. They have to be brought on board in some sort of environment, usually in a bid environment. And then in order for to have a set of structural drawings to bid, then the design team has to produce those, all to create that early mill order package for the project. So because of that, the need to start detailing created several of those things that happened early. So as we were talking, and working through this and have looked at it on multiple projects, is there a better way to do it? Is there a better kind of to reformat that? So instead of, waiting everything be dependent, is there a way to hire the detailer earlier? Is there a way to engineer those connections, as Taylor said, the big risky parts of the project? Can those get brought on board and figured out sooner? That then can be used to create an advanced bill of materials and then to produce structural drawings and bid the package out and then hire the fabricator. So is there just a way to kind of reformat what we were going to do?
Great. So in response to all of those trends, what was done differently on GEODIS Park? Is that?
Yep. Yeah. So I think, Taylor, you want to talk a little bit about this?
Yeah, sure. So our typical method is what we're showing here, right? So a traditional method is basically our skilled fabricator. They own the detailer below them. To Justin's point, we effectively make a selection, and then that effort takes place post fabricator being selected. Here we kind of flipped the script a little bit, and so our integrated approach, which really revolves around collaboration and having an intentional plan from the beginning, was to simply take some of these associated costs that would typically live below the fabricator and move those dollars forward, which working with CAA Icon and the team to have a collaborative approach and get an alignment to do this was key to the success. But we were able to pull some of these dollars forward. So the connection design was completed through Walter P. Moore. And then Mortenson, we actually hired MXE directly to generate the LOD 400 model. And making these shifts of taking the money from typically where it would have existed earlier on in the process allowed us to reduce risk on the project and then in turn have a very successful buyout process as well.
And I think there's an important distinction to be made here that those are dollars that are just pulled forward. They aren't additional dollars, and it's a function of when, not if, they're going to be spent.
Exactly.
Right.
Great clarification.
Yeah.
Yeah. So talking a little bit, we're going to go through some technical terms here, talking about level of development. This is from the Beahm forum document. So these are going to be standard industry terms of level of development 300 and level of development 400, and what that really means for a project in terms of actually, getting stuff done. So these again are from the Beahm forum document. LOD 300 is sometimes referred to as a stick model. You can see it's basically every model element graphically represented in terms of quantity, size, shape, location, and orientation. So a lot of times because of that, it's referred to as a stick model. So again, it has every piece of steel, the correct member size, the correct orientation, the correct length for that, so that a fabricator from that can produce a mill order. But then when you take the step to LOD 400, you can see the key difference there is that it has detailing, fabrication, assembly, and installation information included. And that's the big jump to that's actually then going to be what is going to be fabricated, how big are the bolts, what are the bolts spaced at, what sort of weld information needs to be there. Is the piece, it's ordered at, we have a 42'6" grid. Okay, well, what sort of, how does the connection play into that so that it gets cut to 44 feet, 5 7/16 of an inch? That's all the information that has to be there. So getting from an LOD 300 model, again, used for a mill order, that's what we need to order each stick of steel on the project. But the LOD 400 for fabrication is a big jump forward. And the amount of information that then is included in that LOD 400 model is an order of factor of 10 more than what you would see in just the LOD 300 model. So here's a shot from the Nashville SC, the LOD 400 model that was produced as part of the bid document process. So you can see all here on the right side of the page, all the elements that are included in that process. So kind of zooming in, you can see, we've got gusset plates in there. Again, this is, as Taylor was talking about, a lot of the risk of these projects can lie in the connections and how all these different parts and pieces come together. We've got a steel column, and then the purple part is the canopy up above. So how does that column going to be supported on the main, how's the canopy going to be supported on the main column? We then have the main steel raker that goes to support the precast, and there's little seats that have to support the precast to give it a flat portion. We have every single bolt, every single weld, all of that has to be in this true LOD 400 model. So kind of what gave us the confidence that we could actually pull this off? Because I will be honest, when we first talked about this, and then ultimately when we delivered that first model, I was as nervous as I've been on any single project, because we are saying that all this is here and it is ready for the fabricator, in our case Lejeune, to really start to blow and go on the production of this.
One thing to add on to that, Justin, if I may, is the LOD 400 model that's generated too is non-shop specific. Yep. And I think that's kind of a key fact too, is it's created in a fashion where any fabricator can use it. They simply need to basically take the model, make it specific to their floor and their equipment that they're using, and they're ready to start fabrication. And so it streamlines the process significantly. Just the one thing is probably worth noting for folks listening in.
Definitely. Yeah. Thanks for pointing that up. I forgot about that one.
Yeah, you're good. So inspiration for why we did this, as you can tell, there's some excitement around it, but I think I dropped the word collaboration before, but the biggest key to making something like this happen is truly having team alignment on what we're trying to achieve. And so Populous, Mortenson, and Walter Moore all worked together on Minnesota United, Allianz Field, the stadium you're seeing here. And this was kind of like the first baby step into where we wound up for Nashville. So the tubes that wrap around the facade there behind the PTFE, we call them driver tubes, but thousands of lineal feet of radius steel pipe basically is what was the structure behind it. And this was our first stab at basically an LOD 300 cloud shared model between the design team, Mortenson, and our selected fabricator on the project. And Justin, I don't know if you want to elaborate, but this was kind of what broke the mold and truly an integrated team approach in eliminating some of the 2D document review. Yeah,
and so like Taylor said, we had thousands of lineal feet of this driver pipe going around the building at Allianz Field. It was undulating. Each pipe had a radius to it, and start and end points were different for everything. And as we were going through this, just trying to document this on a 2D set of drawings was really, we were able to do it, but then how was this steel fabricator's detailer going to have to build off of that again? And so we were talking, it's like, well, we have this information in 3D already. We have this central data file, cloud-based data file that has all the complex geometry information. We could then push that to Tekla that has all that exact model geometry precise. Don't have to worry about it. No questions asked. And so then we were able to do that and push it directly then into Tekla for the fabricator. So that as the fabricator was going through that, rather than them trying to create curves and radius points and XYZ coordinates of each single driver pipe, it was all there. They just were able to bring it into the rest of the model that they had coming in. So it saved them a substantial amount of time, and it gave the whole project team the confidence to know that the geometry was right, that we had this incredibly complex geometry, but to know that it was 100% right for the project team. And so here's a couple views of the shop. You can see kind of I like the picture on the right because it really shows how much radius we have on the driver pipe that's going through there. And then actually as it kind of got built up in the field, Taylor was reminding me that every single one of these pipes got fit up fine, that we didn't have any issues with fit up during the erection process. And then you can see ultimately, produced a great design, great collaborative design for that process.
It's worth noting too. I mean, there was some concerns on how are we going to survey and install all the steel to allow the successor work to take place. And to Justin's point, every steel member fit. Nothing got sent back to the shop for refabrication, and there's not a single expansion joint within that system. It's pretty amazing what actually took place, and that's kind of what gave us the momentum to segue on to taking this to the next level.
Yeah, and also along with that, there was another soccer stadium project down in Austin for their expansion franchise where a different office of Walter P. Moore was engaged, and CAA Icon was also engaged again as the owner's rep on that project. This project was about a year ahead of the Nashville project, and because of real schedule constraints, that project had opted for a similar model where Walter P. Moore and MXC was producing the Tekla model in that process. And so I think, I don't know, Brent, I don't want to speak to you guys, but I think that kind of helped give CA Icon the opportunity and confidence to push it forward on this project as well.
Yeah, anytime you can move things from, anecdotal, to substantive, we've touched on this before, and we think there are additional strides and advancements to be made in something that worked. That certainly makes it easier to sell.
All right, so kind of moving into how did this work, Taylor, from a schedule standpoint?
It's a great question. I think one item that isn't pointed out in here that's worth talking about for our integrated approach is we actually started to have these conversations April of 2019 is when we decided, and we were meeting with Populous, Walter P. Moore, and CA Icon on how can we truly take this to the next step and what's the plan we need to implement. And so I think being extremely intentional about being unique and trying to reduce risk doesn't just happen, right? It needs to be thought through and planned out well in advance. So the top schedule is just a typical steel delivery schedule. And really, I think what we wanted to highlight is you run a steel bid package. We'd have proposals turned in 3 to 4 weeks after, take a couple of weeks to a month by the time we actually make a selection, get a contract signed. We get 100% CDs out and ensure that the documents are completely ready. And at that point, they're going through and they're creating their own model, right, to an LOD 400 capability. They're starting shop drawings. They're getting their mill order going. They're trying to figure out where all the high performance coatings are. There's a significant amount of work that goes into it, and it can take 7 to 8 months from when they actually are brought on board to when they're actually starting steel on site, which can be a constraint sometimes for the project. And so with how we ended up delivering the project is shown below in blue, but really the connection design started well in advance, right? Being that was actually being completed by Walter P. Moore. We had 100% CDs delivered after that. We were able to push out the date we had to run our RFP to try to get proposals for steel because we had less of a lead time. And so we had an LOD 300 model in our hands when we hit the streets that allowed everybody to understand the full extent and tonnage required. They had 100% CD documents that were available. The trade partners turned in proposals, and that's when we started our vetting process. And then with a shortlisted group of fabricators, we sent out the first half of the Tekla model, and we actually organized how it was delivered so that we got the most complicated components in the first half of the delivery, and then a typical structural bay on the east side. That way, all the fabricators, even though they didn't have the entire model, could extrapolate with the same details wrapping around. And so it allowed us to get firm numbers from all of our contractors. And the key here is reducing assumptions. It was crystal clear what they owed us. They weren't trying to fill in the blanks. The challenges we faced with high performance coatings, understanding the extent and how much touch up is going to be needed based off of the erection plans, was reduced significantly. And so we ended up procuring the steel package off that first half of the LOD 400 model. Took a couple weeks after that to get a contract out the door. They placed their steel order, and about 5 months later, roughly, we were starting to swing steel on site. So it was a very streamlined process. And the great thing was, when they started, they weren't getting shot out of a cannon. They were able to learn, get up to speed, and it wasn't a mad dash. And I think that, the first month after selecting a contractor is a huge timeline to set up success and how the project is actually going to go. And it was very thoughtful, smooth, and revolved around teamwork and communication. And that just carried on throughout the duration of the project.
Yeah, and I think that communication, by being able to push that out, rather than awarding the steel package based on 50% CDs, but instead being able to award that steel package after 100% CDs. I know for my side, working with Bruce and the Populous Hastings teams, it allowed us to coordinate a lot more of these connection details and just final things that happen over the course of towards the end of a project. Elevator shaft size changes, or we have to adjust a cladding edge detail as something wasn't quite figured out at 50% CDs, but then we figured out, okay, this is what needs to happen for that. So I don't know, Bruce, do you have any other comments from that design standpoint side of that design extension?
Yeah, I completely agree. Any additional time we can get to coordinate is a bonus in my mind, because the schedules are so reduced to begin with. I mean, one thing that really comes to mind is how these buildings are changing. Just the amount of technology that's going into these buildings for Wi-Fi, DAS, the miles and miles of conduit and things that have to get coordinated, and this gave us an opportunity, I think, is one item that comes to mind and I think we'll dive into some of those images later, right, Justin?
Yeah, we got those going
on. But that definitely gave us some time to work and get some of those details ironed out.
Yeah, it certainly makes it more intentional as opposed to an afterthought for a lot of the follow-on work as well.
Yeah, and the other thing to kind of point out is that, even though the connection design started officially kind of in January, we had already started, having some initial concept back even like in early design development in late 2019. But again, by having our Walter P. Moore team do, all the member design and the connection design, we're able to overlap that quite a bit in terms of knowing that, okay, hey, a lot of the typical floor framing, that was already figured out by about, February. We could start doing, beam to column connections, beam to beam connections, things of that nature, and start working through even some of the more complicated, complex connections that were going to be repetitive across the building. We could still get that, buttoned up and started in February and March, while other parts of our structural team were coordinating cladding details and other things of that nature. So that really enabled us to have a really strong set of drawings, and like Taylor said, the model, even having that model right away from the beginning when it first went out to bid, to have that model as part of the process.
Something else to add on to here is, for once, we didn't have to battle what's structural and what's missed metals. If it was in the model and it was shown clearly, the structural steel fabricator owned it. If it wasn't in there, our miscellaneous metals contractor had it, or somebody else specifically in their scope. And I think it's one of those scopes that's just a headache, right, for us, and can present challenges. And at least Bruce and Justin, from what I heard, it was quite straightforward for a change, which was great.
It was, and I think kind of Taylor, going back to what you'd said earlier, that having the model that gave everybody a platform and a baseline. So if something changed after that, it was a legitimate change order to the steel fabricator scope, and you didn't have to argue, oh well, that was kind of shown in this detail or wasn't shown in that detail. It was crystal clear. So I think you'll see a little bit more as we're talking. I think it helped everybody feel like we were on the same team a little bit. That you didn't feel like, I know I didn't feel like, oh, we were going to get nickeled and dimed on any little change, because it was a clear baseline for everybody to know where we're at, what was included, what wasn't included.
All right.
So something we want to hit on really quick here too is steel sequencing is handled in a number of different ways. Typically, on this project, Mortenson, Messer, we took it upon ourselves to go through and sequence the job early on during the design phase, to the point where then MXC and Walter P. Moore could put all of the specific sequence numbers in the stick model and the LOD 400 model, which was awesome. So the schedule we bought out our contractors off of aligned with the LOD 400 model, which was a great buyout tool. And then we were able to actually carry the sequences from buyout all the way out through completion of the project, which was great. So the design team didn't have to go back and renumber the model. We didn't change any of the sequences. It allowed us to really efficiently move from the schedule we generated into production of steel and then implementation in the field. And so I think just being intentional about how we plan the project can make a big impact on the operations side.
Yeah, wonderful. And kind of just to dive a little bit deeper into the connection engineering side of it, for folks that are out in California or on the West Coast, typically it's the responsibility of the structural engineer to design and detail all those connections out on the West Coast, typically from their high seismic requirements. That's not how it's done here in Central Tennessee or most in the eastern part of the site. Eastern part of the country. So these are the connection details that our team was developing, every single beam to beam connection, every beam to column connection that we had there, brace connections coming through there. So again, that's a lot of the work that can be ongoing, and being able to overlap that as instead of pushing that all off onto the steel fabricator and their detailer, we could have that happening simultaneously to the rest of the design. But then we really get into these complex connections, as Taylor was talking about. If you remember that picture earlier he showed, and the same thing here, these are the risky spots to the project that can cause delays and a lot of the unknowns, right? In terms of, well, how big is this gusset plate? Is it 1 inch thick? Is it 2 inches thick? Is it, how much weld do we have to have? Is it a CJP weld? Is it a fillet weld? And so being able to have this information, and we had these both in a Tekla model, but then we also produced these 2D representations as part of the bid set, so that if a fabricator was preferring to go through and kind of look at PDFs as they were preparing their bid, but also could go to the model and extract these quantities right away. So it gave both sides of a side there for how to have that happen. And also, from a design standpoint, it let my team work with Bruce's team to figure out, okay, what is the design aesthetic of these connections want to be? Does it want to be a large gusset plate? Do we want to have gusset plates that come in off the side? Do we want to have cap plates? What do those want to be? I forget, Bruce, if you remember. Like, I felt like we went back and forth probably half a dozen times on kind of going through these connection concepts during the design phase.
Right, to be able to have that interaction with in a team approach was huge.
Yeah, and then as Bruce mentioned, the amount of technology that's going into these buildings is so much more, even just than 10 years ago, let alone 30 years ago. And so being able to kind of figure out how are we going to route all these utilities going around the building, and as Brent mentioned, a thoughtful manner. So like what we actually did here was, we knew that there was going to be some conduit running up here for speakers, for Wi-Fi, for DAS, for concourse TVs, actually kind of creating some pathways for those that again are intentional in the process to allow space. We don't know exactly what's going to be in here, but we've now given them a path to be able to go through for that. And similarly, and again, these are all shots from the LOD 400 model that was ultimately delivered to the fabricator. We stopped some stiffeners short so that the conduit could run up behind. And then here at the front of the bowl, we added a couple holes here coming out of from those two beams and then going back here so that the drain pipe from the precast could be routed through those as opposed to having to be routed underneath those. And so when you look at what actually got built, this is actually the drain pipe's already installed here. You can't even really see it. So as you're walking through the concourse, you're not able to really see that. It creates a really clean visual line going through the spaces. If you zoom in underneath, then now you can see the black drain pipe that's kind of in front of the beam. That again, by being able to, again, going back to pushing that influence curve up, spending more time and effort early before this gets out to the field or before it's ready to be fabricated, and you get an RFI saying, oh, well, how big does this hole need to be, or where does this hole need to be? We're able to, again, do it thoughtfully and intentionally. And then you can see kind of another finished shot here of that same column going up through there. So Bruce, you want to touch a little bit on coatings?
Yeah, this is another great tool. Benefit of this tool, I call it a tool because it really is. To be able to have a collaborative approach. I remember some of the specific coordination meetings we had, talking with some of our team members, how beneficial this was to be able to just walk through the model with the whole team and make decisions, on the spot. It's so evident just to be able to, instead of the old approach of, shop drawings being sent and passed around 2 or 3 times, this is so much more efficient in the use of people's time.
Yeah, and Taylor, you want to talk a little bit what it was for you from your buyout perspective?
For sure. I mentioned before, but high performance coatings, especially on our sports projects that are open air, right? There's an incredible amount of steel that gets coated. And typically, right, Bruce, there's a finish drawing in the architectural sheets that helps to indicate where high performance coating should be, and we can identify where fireproofing is for what's raw, et cetera.
Right.
There always is challenges with identifying all that on a 2D drawing and ensuring it's accurately communicated. It's just the nature of the industry. And so it was actually an afterthought partway through to say, can we add in paint? And the answer we all said was, yeah, that'll be pretty easy. So we added in all the finish. So what's the finish of every steel member supposed to be throughout the project? Which is something we always spend a lot of time on during buyout, is how much high performance coatings do you have? And the disparity between proposers can be drastic on a job, and everyone's looking at the same set of documents. With this, it was, once again, to Justin's point, crystal clear and cut and dry what finish went on what member. And we really didn't have to have little to no follow-up on the extent of high performance coatings or battles on the incorrect finish. So I think this was something that was a drop in the bucket, but made a massive impact on planning and execution.
And that was kind of an unintended, right? Like, that wasn't something you were anticipating as a benefit from the lead into this. It was, just a byproduct more.
Yeah, it was a thought halfway through on, gosh, this would be awesome if we could include this. And I think everyone said, well, that won't be that bad. Like, we're starting to have the discussions right now anyway. So I think just having, once again, like the trust and open communication and willingness to ask what's possible allowed us to kind of do things differently.
I just may deviate just a little bit here, but one of the things when I joined the project that I was struck with was the level of trust and collaboration that the team members already had. And we know that isn't always common in this industry. But I think, it had its roots in some of this process here. So again, just another unintended consequence.
Yeah, agreed.
Agreed. What about one more unintended consequence, Taylor, on anchor rods?
Yeah, so one of the challenges with shortening your procurement, or essentially pushing the buyout date out, right, because we can get steel at a quicker rate and we're more efficient, was we didn't have time in one of our coordination meetings. This was December of 2019, I think, or in that time frame. We'd said, oh, how they can't create, our fabricator won't be able to create shop drawings for anchor rods and embeds. And the decision was made there, well, why don't we have them created as part of this deliverable? And that'll allow us simply to, they'll have a set of documents they can submit. They can just simply create the templates, have the rods threaded, send them out to the job, and send the embeds out, because we were starting concrete very quickly once we started the project. Bruce gave the run through the service level, that deepest portion. Within a matter of weeks to a month of starting the job, we were down there working on foundations. And so we needed to get anchor rods and embeds on site quickly. And so MXC ended up creating all the shop drawings for any embed that's cast into a concrete element, as well as the detailed shop drawings for all the anchor bolts, which was fantastic. We were able to get those on site in time. We could have our coordination meetings and get them installed with I think, Justin, quite few issues from the installation side as well.
Correct. Yeah. And I remember Lejeune Steel, when we were talking to them about the project and what went well and what didn't go well, they mentioned that, anchor rods for them is always one of the first things, right? They get hired, and then, 2 days later, the superintendent in the field's asking, where are the anchor rods, right? And so for them, it onboarded them in a smooth way. It provided them a really good on-ramp to say, okay, this is already done. The shops are approved. You just need to fabricate it, as opposed to then being like, oh, we have to go through the whole submittal process. First, they have to create a shop drawing, and that shop drawing has to be submitted, and then we review the shop drawing, and then, oh, actually, they misinterpreted this part of the drawing, or this has changed from the first drawing set to what it's at now for whatever reason. And again, being able to, incorporate all of that in the model and in that initial process, just led off to a super, super good start for them in the job. And especially on these large sports jobs, particularly anchor rods, it's not everything's just this little 2x2 small little column. We end up with, some pretty substantial anchor rods and layout patterns. So it's not a trivial manner to be able to get those in and coordinated. One other item that I wasn't expecting was just the RFI process. And like in a traditional steel delivery, a detailer creates a question, that then goes to the steel fabricator, that goes to then the construction management team, that then gets uploaded to the architect, who then passes along to my structural engineering team. We review it, and then it goes back to the architect, back to the construction manager, back to the steel fabricator, and back down onto the detailer. And so that and I think if everybody's seen one of those, you just end up with there's 8 cover sheets to the RFI before you even get to the question in that process. And so here in the integrated approach, we had a detailer. They were able to go straight to the structural engineering team. We would discuss it and happen, and then get the answer back right away, even before the project had gone out. And so it just a much simpler, smoother process, and eliminated some of those the mind-numbing, time-consuming aspects of the project. So I just think it, like Bruce and Brent were saying, and it just really helped, I think, create this much more team atmosphere for that, in terms of, when things came up, everybody just felt like they were kind of outside their silos a little bit more, and a lot more collaborative to that. So big question, Brent, was it worth it?
Yeah, was it worth it?
So kind of just a reminder of what we were trying to do was, reduce the risk of the project, and schedule risk and cost risk by pushing that influence curve up, and then, did it in a way of pulling out the connection design and the LED 400 modeling, ahead of time. The owner made that investment early on in the project, and I'll let Taylor take it away from here.
Yeah. So simple chart, but really the intent here is to show our budget is on the left-hand side. The little gray bar above was the portion that's connection design and technical modeling. And so we have that same gray bar shown on the right, but the blue is the actual contract, and it should be the contract. That buyout is blue, and yellow is our savings, essentially, that we had from the budget to the final buyout value. I got to admit, I was a little shocked when we ran the numbers. I forgot how successful it was, but we came down about 12% from the budget to where we landed. And the best part about it is it's really allowing our trade partners to be comfortable and ensuring that there's clarity in what they're signing up for, allows people to sharpen their pencil, right? And they're They're not putting additional contingencies in. They're not hedging their bets. It allows people to be very confident in what they're proposing on, and we can have the same confidence in hiring someone. And really, the stat that drove it home for us was for change orders, we're at about 2% of their contract value at the end of the day, which is almost unheard of for steel, where it's not out of this world to be 10 to 15%. And so we're really proud of that final result. And to Justin's point, there still can be change, but the ability to manage the change and have a discussion when there's that level of clarity is very simple. It's factually based. You can move through the change order process quickly and without emotion. I think that really paid off on this project.
Yeah, and a few other ones. Like I said, the RFI reduction process, we were down 90% of RFIs compared to what we've seen on other projects of this similar scale and complexity for that. The 12% steel buyout savings, 4 weeks leading to 7 weeks. Bruce, you want to talk about that?
Well, yeah, I mean, it was a shocking thing. I mean, how often do you get on a large project like this, and then towards the end of the project, you get called to a meeting, and hey, gang, we're gonna open this project up 6 weeks before scheduled delivery, and I can only imagine I was ecstatic, and I can imagine from the owner's side getting that news of, wow, I get the building 7 weeks sooner. I can start earning revenue on this building 7 weeks sooner. I mean, it goes on and on, the benefits of what we were able to achieve here. I mean, by using this delivery method, and this was one of the main reasons we were able to get there. So if I missed something there, you guys feel free to add on to my story.
Yeah, you're good. I think steel finished 4 weeks early, which is a pretty major accomplishment itself. But getting the critical path pulled up that far, and I think Justin talked about unintentional consequences, but that momentum carried through the rest of the trades. Yeah. And so we're able to your point, Bruce, keep the cadence up and turn it over 7 weeks early, which is something we're proud of as a team.
Yeah, I'll say, speaking on the owner's behalf there, this was hugely valuable to them because it allowed them to play the entirety of a season in GEODIS Park as opposed to splitting time with another facility.
Yeah, and one other stat that kind of blew me away was 0. We had 0 revise and resubmit steel submittals. This is the first and only project in my career that I've ever worked on where we didn't have a single, not even one steel submittal was marked as revise and resubmit. So, and just showing the clarity and of the process for that, and ultimately, going back to our theme of breaking the mold, right? It was one incredible project success for all of us involved.
Yeah, to me, the question, after seeing all of this, shifts from, did it work to why wouldn't you do this on every project, So fantastic. I think are we at our Q&A opportunity here, or are we?
I think so.
Through the slides. So.
While Brent's pulling those up, one other kind of little anecdote was that when we had an out event, it was in Nashville, so the whole project team took the advantage to get together and spend a fun night down on Broadway with the structural engineer, the architect, the owner's rep, the steel fabricator, the detailing team, the erector, kind of going back to the camaraderie that everybody had. There haven't been too many projects again where I've been on at Steel Topping Out where everybody feels whole and everybody feels that it's been a good project for them. And everybody kind of enjoys and wants to go spend some time together.
That was fun for sure.
Sure was.
Yep.
I'm not seeing any questions here, so
All right, we're efficient.
I think we have covered it.
So I have a question for Taylor.
Uh-oh.
Yeah, answer it if you can. But I'm
Okay.
curious, how was this process received by the steel trades on bid day?
Awesome.
Yeah.
I think that's a good question to bring up, Bruce. So before we actually implemented this, as we were getting budgets throughout design phase, we were presenting our proposed procurement method to all the parties who were helping us to budget the job, right? And we received some mixed reviews along the way, I'd say. Part of it is control, and so I think some of the fabricators we talked to, including Lejeune, who we selected, was more. They were hesitant at first with all this being pulled up, right? Because there's a concern on how are you able to impact the design and make it so it's favorable for their shop's fabrication. And in the end, after going through this process, they couldn't have enjoyed this more. I know for them, this was a very smooth and productive effort. I know they're looking forward to doing this again, and other trade partners are. So I just think that trust piece is huge, and having a little faith in each other, as hard as that can be in the world we live in, really makes a big difference.
Yeah, that's good to hear.
Good question. I did get a question here on the chat from Christopher. Was there any specific trades that benefited from this delivery besides the steel team?
I would, Justin, you can answer after, but I think one of the other items that was huge was the ability for all the other trades to coordinate through VDC was massive. And so you think about, we had this model before we were really even in the dirt working, right? So the coordination for all the successor trades had a model that's far more accurate than what we may have had historically on other projects, and we're able to better coordinate and plan their work. And I think that's one of the ripples we felt throughout the successor trades.
Yeah, and if I don't know if the slides back up, this is a shot from one of our weekly structural coordination meetings, and this was just talking about the uplight stands that were going to be mounted to the canopy, and figuring out and realizing this was only about 4 weeks after the steel fabricator had been brought on board. So after Lejeune had been signed up, that we had the fully connected model with all the bolts in there, and so as they were trying to locate this, it was kind of we could the light cyan blue is the standoff or mount for the light of knowing, okay, well, we can't have the standard hole or whatever the standard size was. Well, will that fit on the flange? Will it fit in between the bolts? Little things like that kind of I hadn't necessarily thought of, but again, having that sooner, it allowed all this other everything else to be able to move forward, and the coordination that was waiting to happen until a month before that material was going to be on site, now it could happen 3 months before it was able to be on site. So again, that kind of, as Taylor said, led into then being able to finish the overall job 7 weeks early.
MEP for sure saw a massive benefit just with the front end heavy coordination they have.
Great question. Great answer. Any additional questions? Well, look, we certainly appreciate the opportunity to share the success here, what went well, some of the carry-on unanticipated ripple effects from this approach. I think there's a winner here. I think all of our firms would certainly say, and the owner would say that, they're proud of the work, they're proud of the end result. Really, a fantastic all-in-all project. Another question here. We'll just keep rolling from Graham. What did the steel approval packages look like? Was it drawings or model review?
Oh, great question. I took this out of because we were going to be short on time, so I'm glad you asked that. So we actually, again, continued in kind of asking, well, what can we do? So what we had for the steel submittal review process was it was a combination of we had the 2D plans and erection sheets like you would have typically, but instead of having then 800 pages of individual piece sheets, that part was then reviewed in the model. And again, so our team, again, knowing that our engineering team and our connection team and our modeling team are all working together throughout the process, that we had a lot of confidence in, could know we could check various members. But again, it saved the fabricator a substantial amount of time and effort in terms of creating all those individual 2D fab sheets for each individual member, that those didn't have to be created and submitted. Instead, we were able to just the detailer, we have a proprietary software that we can mark up in a 3D modeling environment for that to be able to get different comments included in there. So it was a combination of both model review, but we still did have the plan review for some of the like cladding edge bent plate dimensions. Those are a little easier to show on plan in a 2D drawing, as opposed to trying to show in a model and figure out, okay, what's the dimension of the bent plate from the center line of the grid? That stuff and like was really a lot easier to still able to stay in kind of a plan document.
That was a big discussion. I know as we were
It was.
that number at 19, how do we document this appropriately, right? To ensure that we're fulfilling our commitments for reviews, but not just creating duplicated effort. So
yeah, and I looked it up. I think we had 150 steel submittals on the job, and about 50% of them were returned in 3 days or less. And then I think our average was about 6 days in there. So again, it made the process so much smoother, so that we did count on some of that time savings. And honestly, some of those ones that drug us down a little bit at the end were some smaller submittals that we honestly maybe didn't quite prioritize and get turned around as quick as we could have.
Honest. Just a question from me. How do you see this approach evolving in the future?
who wants to take this one first?
I think I'll say I think continuing to try to be able to. We had a substantial amount of savings on the project here at the end. Is there a way to kind of have more of a database so that we can have some of that savings earlier in the project to be able to if at the DD timeframe or SD kind of as we're budgeting, how can we do that a little bit sooner and quantify some of those potential savings or schedule savings sooner? I think the one thing that I would really hope is that we can implement it to look at the process as a whole, and again, finding ways to push that influence curve further and doing more stuff in a virtual setting as opposed to trying to figure it out in the field.
I'd say we're obviously all here talking about this because we want to implement this again moving forward. But I think it's having the mindset early as a collective team on what can we do differently, right? And how can this project continue to push the mold on a collaborative approach? And so I think just be willing to try new things, ask the questions, and actually sit down to have the dialogue, right? Because what maybe wasn't possible 5 years ago may be possible today.
All right.
All right. I'm not seeing any additional questions, so. Shall we call it a wrap?
Sounds wonderful.
I think
Like
we
a
can.
wrap.
All right.
Thank you,
Well,
everybody. Appreciate it.
Thanks,
big
everybody.
thank you to everyone.